This is a key to section 11.1 part A, and that's where you had to solve quadratic equations. So all of these are quadratic equations, and you want to solve these using a square root property. Now always make sure you're following directions. So if it says use square root property, use square root property. If it says factoring, use factoring. If it says use quadratic formula, you use quadratic formula. So always follow directions. Okay, and so just remember that the square root property basically says this, and it's got to be in this form. It's got to look like this when you can go directly to the square root property. So you have um, some expression involving x and is being squared, and that's going to equal a number. And so you have a number on the other side. Also note that you want this coefficient or this number in front of this parentheses to be a 1. Okay, so that's a 1, and you have a variable expression, something involving the variable x within this parentheses that's being squared, so that's part of your base. And that's equal to a number, not a number times x, but a number, can only be a number. Then we can take the square root of both sides. So basically it says if you have x squared equal, let's say b, where b is a real number, that must be a real number. Okay, real number. So it could be positive or negative. Then you would take the square root of both sides. Now remember, we also talked about the fact in the previous lesson that when you take the square root, we're talking about square roots only, that when you're taking the square root of both sides, you're going to get a plus or minus. All right, and so the square and the square root undo each other, so you get x equal plus or minus the square root of b. Okay, so that was one of the properties in a previous lesson. Okay, so we're going to use that idea with these. So if you look at number 1, you have x squared equal 20. Now, you notice that the variable expression is being squared. Out here, that's a 1, and that's equal to a number. So it is of this form. It looks just like this. So once it looks like this, then I can take the square root of both sides. But don't forget, you get plus or minus. All right, now remember, the directions will say to simplify all answers. So I'm going to get, now remember, the square and the square root, they undo each other. So if you're squaring, the opposite of squaring is to take the square root. And so you get x equal plus or minus the square root of 20. I can simplify the square root of 20 based on our previous lessons. So we get plus or minus the square root of 5 times 4. And that's going to be plus or minus 2 square root of 5. So that's your solution. Okay? So those are the two solutions, a positive 2 square root of 5 and a negative 2 square root of 5. That when you plug it back into the original problem, you're going to get 20. So the left side will equal 20. Okay, now in my math lab, remember in math lab, they're going to ask you to write it as two separate solutions using a comma. So you're going to say x equal 2 square root of 5, comma, negative 2 square root of 5. All right. Now if you want to check, let me just show you how to check one of them. Let's check negative 2 square root of 5. Let's see if that works. So we'll go back to the original, just to remind you. Always go back to original equations. That was the original equation. So in place of x, I'm going to plug in this number right here. So negative 2 square root of 5. And don't forget you're squaring it. Okay? And you want to see if that's going to equal 20. That's your goal. All right, well remember, anything, so you have this basis being squared, so that means that negative 2 square root of 5 has to be multiplied by itself. So negative 2 square root of 5 times negative 2 square root of 5. And then let's multiply the whole number parts. So negative 2 times negative 2 is a 4. The square root of 5 times the square root of 5 is going to be 5. But if you don't see that, then say the square root of 25. And the square root of 25 is 5. So you get 4 times 5, which is 20. And that's what you wanted. Okay, so that's one way to check it. All right, number 2. You have x squared equal negative 49. X squared equal negative 49. So again, it's already of that form. So it already looks like this. So I can take the square root of both sides, plus or minus. And so remember right now I was squaring, so the opposite of square root is square root. So that's why you take the square root of both sides. And the square and the square root undo each other. So you get x equal plus or minus the square root of a negative 49. And we know that the square root of a negative 49 is 7i. So you get x equal plus or minus 7i. So you have two solutions. Your solutions are positive 7i and a negative 7i. Now in my math lab, you would need to write it as x equals 7i, comma, negative 7i. So either one of those is fine. All right, number 3. I'm going to go back and put the answers on here. So the answer to number 1 was, now it didn't say show works. You just have to put the answers. So number 1, the answer was x equal plus or minus 2 square root of 5, but you did have to simplify. And number 2, the answer is plus or minus 7i. Okay, now number 3. Let's look at number 3. So number 3, you have 4x squared equal 32. Now, technically, I can, if I wanted to, take the square root of both sides because that's a perfect square, so it's not going to mess me up. But let's just go ahead and just follow the procedure. So remember follow the process. So remember, you really would like a 1 here. So I'm going to go ahead and divide both sides by 4. So I'm going to get this. I'm going to divide both sides by 4 because I want to get that x squared by itself. So I get x squared equal 8. All right. So 32 divided by 4 is 8. Now, right now I'm squaring x, the opposite of squaring x. If I want to get x by itself, I would need to take the square root of both sides. So you take the square root of both sides and don't forget that plus or minus. That's an easy thing to forget. Because remember, let's just look at x squared equals 16 and make sure you understand why you're going to get a plus or minus. See, you're squaring a number. So, and I want to ask myself, what number times itself is 16? Obviously, it's easy to see that one of them is 4, because 4 times 4 is 16. But many people forget about the negative component. What about negative 4? So negative 4 times a negative 4 is also 16. So that's why you get plus or minus, that plus or minus symbol. Okay? All right. So the square and the square root undo each other. So you get x equal plus or minus the square root of 8. And then if you simplify, well, actually, you need to simplify. So you get plus or minus the square root of 4 times 2. So the square root of 4 we know is 2. So that's going to be plus or minus 2 square root of 2. So that's your solution. All right, so number 3, you're going to get x equal plus or minus 2 square root of 2. All right, now number 4. Let's look at number 4. So number 4, you have 3x squared equal negative 12. All right, so again, we want to get x squared by itself. If you take the square root of both sides, you're going to have an issue because this is going to be a square root of 3, and you're going to be dividing by the square root of 3, and you're not going to know what to do with that square root of 3. So to be on the safe side, get that x squared by itself. So right now, multiplying by 3, the opposite is to divide by 3, and it's going to make things a whole lot easier for you. So x squared equal, and this becomes a negative 4. All right, so I'm trying to get x by itself. I'm trying to solve for x. Well, right now I'm squaring. The opposite of squaring is to take the square root, so don't forget that plus or minus, though. So the square and the square root undo each other. So you get x equal plus or minus the square root of a negative 4. And we know that the square root of 4 is 2, so the square root of negative 4 is 2i. So x equal plus or minus 2i. All right, so we get x equal plus or minus 2i. Now remember, you can write it as 2i comma negative 2i. Does not matter. All right, number 5, you have x squared minus 28 equal 0. So again, you want to get x squared by itself. So I'm going to add 28 to both sides. And so combine like terms, that's a 0. Combine like terms here, that's going to be 28. So I get x squared equal 28. And now remember, trying to get the variable x by itself. So right now I'm squaring. The opposite of squaring is to take the square root of both sides, plus or minus. So the square and the square root undo each other. So I get x equal plus or minus square root of 28. And remember, you got to simplify this just like you did in previous lessons. So the largest perfect square that goes into 28 is 4. So you get plus or minus the square root of 4 times 7. And the square root of 4 is 2. So I get plus or minus 2 square root of 7. That's number 5. So number 5 is plus or minus 2 squared root of 7. Okay, now number 6. Number 6, you have x squared plus 40 equal 0. So x squared plus 40 equals 0. So just like number 5, you want to get x squared by itself. So here I had to add 20 to both sides. So here I'm going to subtract 40 from both sides. Right now I'm adding 40, so the opposite of adding 40 is to subtract 40. So what I do to one side, I do to the other. So when I combine like terms of 40 and negative 40 is 0. So x squared plus 0 is x squared. 0 and negative 40 is a negative 40. And now I'm going to take the square root of both sides to get x by itself. So right now I'm squaring. The opposite of squaring is to take the square root. But don't forget that plus or minus. So I get, now these undo each other. The square and the square root undo each other. So you get x equal plus or minus square root of negative 40. And let's simplify the square root of negative 40. So here I can write this as plus or minus the square root of a negative 1 times 40. Now again, you can do some of this in your head. You know that you can have an I out here. Now be careful how you write that I. Be careful. It's not I plus or minus. Okay, it's plus or minus I times the square root. So be careful. So that's why it's a good idea to write in this step I'm about to do. So that's plus or minus the square root of a negative 1 times the square root of 40. So that's plus or minus I square root of 40. Okay, so right in that step so you don't make a mistake, because some people will put the I in front, which is incorrect. It's totally incorrect. All right, now the square root of 40 I can write as square root of 4 times 10. And so the square root of 4 is 2. So the answer is going to be x equal plus or minus 2I square root of 10. So that's your answer. So 2I square root of 10. So that's number 6. So number 6 will be plus or minus 2I square root of 6. I'm sorry, square root of 10, excuse me. All right. Number 7. Okay, number 7, you have 5x squared plus 40 equals 0. All right, so it's very similar to number 6, except this time x squared you have a coefficient of 5 instead of a coefficient of 1. So the first thing you're going to do, though, is to subtract 40 from both sides. First thing you should do. So when you combine like terms, that's a 0. So I get 5x squared left on the left side. When you combine like terms, 5x squared plus 0 is 5x squared. And then 0 and negative 40 is a negative 40. And now that kind of looks like number, see this part here, that kind of looks like this now. So you can divide both sides by the coefficient of x squared. So I'm going to divide both sides by 5. And 5 divided by 5 is 1. 1 times x squared is x squared. Equal, and that's going to be a negative 8. Alright? And so I'm trying to get x by itself. Right now I'm squaring it. So the opposite of squaring x is to take the square root of both sides. Don't forget that plus or minus. So the square and the square root undo each other. So I get x equal plus or minus the square root of a negative 8. So I get x equal plus or minus the square root of a negative 1 times 8. Write in the steps if you need to. X equal plus or minus. Now the square root of a negative 1 is I, so you get I square root of 8. And I can rewrite 8 because the perfect square of 4 goes into 8. So I get x equal plus or minus I square root of 4 times 2. And the square root of 4 is 2. So I get x equal plus or minus 2I square root of 2. So that's the answer to number 7. So number 7, you get plus or minus 2I square root of 2. All right, number 8. Let's look at number 8. Okay, number 8. All right, number 8, you have this. You have 2x squared plus 5 equal 19. So it's just like the previous one, we just did, like this one right here, like number 7, except here you had a 0 and here you have something other than 0. So it's the same thing. So you can subtract 5 from both sides. No big deal. Combine like terms. 5 and negative 5 is 0. So I get 2x squared equal 19 minus 5 is 14. Divide both sides by 2, maybe I get x by itself, so x squared by itself rather. So I'm going to divide both sides by 2. Reduce, so 2 divided by 2 is 1. 1 times x squared is x squared. 14 divided by 2 is 7. Alright, now I'm trying to get x by itself, right now I'm squaring both sides. The opposite is to take the square root of both sides, but don't forget that plus or minus. So the square and the square root undo each other, so I get x equal plus or minus square root is 7. And there is no perfect square other than 1 that goes in at 7, so there's your answer. So number 8, you get x equal plus or minus the square root of 7. X equal plus or minus square root of 7. Okay, number 9. You have x squared minus 2 equal a negative 46. Adding 2 to both sides, I get, and combine like terms, a negative 2 and a positive 2 is 0. So I get x squared equal a negative 44. So that's what I end up with, x squared equal a negative 44. Now remember, let's go ahead and rewrite this over. So now remember, I'm trying to get x by itself. So right now I'm squaring x. The opposite of squaring x is take the square root of both sides. And so when I do that, the square root and the square root undo each other. So I get x equal plus or minus the square root of a negative 44. And remember that imaginary unit. So I get x equal plus or minus the square root of a negative 1 times 44. The square root of a negative 1 we know is I. So x equal plus or minus I square root of 44. The perfect square of 4 goes into 44. So I get x equal plus or minus I square root of 4 times 11. And the square root of 4 is 2. So I get the answer to be, the solution is to be plus or minus 2I square root of 11. Right, so that's number 9. So number 9 is plus or minus right, so x equal plus or minus 2I square root of 11. Okay, finally number 10. Let's see number 10. You have 3x squared plus 4 equal negative 8. So first of all, subtracting 4 from both sides and combine like terms. Positive 4 and negative 4 is 0. 3x squared plus 0 is 3x squared equal a negative 8 and negative 4 is a negative 12. Alright, now to get x squared by itself, we're now multiplying by 3. The opposite of multiplying by 3 is to divide by 3. So I get 3 divided by 3 is 1. 1 times x squared is x squared equal negative 4. So x squared equal negative 4. So again, I'm trying to get x by itself. Right now I'm squaring x. The opposite of squaring is to take the square root of both sides. Don't forget the plus or minus though. The square and the square root undo each other. So x equal plus or minus the square root of a negative 4. So x equal plus or minus. Now, you can skip some of these steps, but hopefully you know that the square root of a negative 4 is 2i. If you didn't, you would have to say negative 1 times 4. The square root of a negative 1 is I. That's how we define the square root of a negative 1. The square root of 4 is 2, but we prefer, so the square root of negative 1 is I, the square root of 4 is 2, but we prefer to write this as plus or minus 2i. Alright, so that's number 10. So number 10 is plus or minus 2i. Okay, so that's going to take care of the key to section 11.1, part A.